Asthma is a chronic disease of the airways distinguished by repetitive incidents of coughing, chest tightness, and wheezing, which is in response to inflammation, airflow limitation, bronchial constriction to various stimuli. Currently, the use of beta-2 antagonists and steroids are commonly used in the prevention and relief of asthmatic patients. There are two classifications of asthma. The most common is allergic asthma, which involves IgE antibodies, eosinophils, and mast cell degranulation, with the other being non-allergic asthma or eosinophilic asthma, which is more severe and causes hyperresponsive airways and non-specific bronchial hyperactivity.
Mechanisms for allergic asthma. Mast cells are resident in the airway wall and their production is increased in airway tissues with the activation of Th2 lymphocytes. Mast cells are receptors specific for the IgE antibody, which is B cell mediated. Once the antigen enters the body, there is an initial exposure. It binds to the IgE receptors on the surface of the mast cells, ultimately causing sensitization. When there is re-exposure to the same allergen, the IgE is able to bind to that same allergen, producing an antigen-antibody complex and subsequent degranulation of mast cells. This degranulation causes mast cells to release a number of factors, such as histamine, leukotrienes, and cytokines. Specifically, in allergic asthma, histamine and leukotriene release stimulates smooth muscle contraction and essentially changes the structure of the airway by causing inflammation and thickening of the smooth muscle layer. There is also differentiation of cells that line the airways, which in turn secretes more mucus. This excessive mucus secretion causes obstruction and barrier to inhaler therapy.
An example of an anti-IgE biologic is omalizumab. It is administered subcutaneously and binds to circulating IgE antibodies, decreasing cell-bound IgE. There is also a decreased expression of high-affinity receptors. These actions result in a decrease in tissue infiltration and mediator release. Omalizumab can lead to hypersensitivity, which begins when an allergen or antigen activates IgE molecules on mast cells, forming an IgE antibody complex. A second exposure to the allergen causes antibodies to bind, and a release of resulting in inflammatory mediators from mast cells. This hypersensitivity mechanism can also lead to anaphylaxis. The exact biologic is poorly understood, however, due to the presence of the mouse polypeptide. There are insufficient studies and therefore understanding as to the direct drug interactions as well with other potential drugs that people may be taking. It could be considered, however, that taking a histamine 2 antagonist such as ranitidine will increase serum IgE levels. Therefore, taking this drug could have a negative effect on those who suffer from allergic asthma.
Mechanisms for eosinophilic asthma. Patients with eosinophilic asthma possess an accumulation of eosinophils within the bronchial tract, resulting in airway inflammation and remodeling. This is attributed to the release of cytotoxic proteins, lipid mediators, and cytokines and chemokines by the eosinophils. Eosinophilic asthma is said to be detected in more than 50% of asthmatic patients, attributed to the role of interleukin 5. Interleukin 5 is produced by a range of different cells, including Th2 cells. IL-5 promotes the maturation of eosinophils in the airways. However, in the late onset of eosinophilic asthma, ILC2 cells rather than Th2 cells are the main cellular source of the production of IL-5. IL-5 exerts its biological actions via stimulation of the IL-5 receptor expressed on the eosinophil surface. The receptor consists of an IL-5 alpha subunit and a non-specific beta-C chain that interacts with IL-5 and IL-3. As evident in the figure, the interaction of IL-5 with the A subunit aggregates and stimulates the JAK receptor complex, which is responsible for the involvement of multiple signaling pathways to induce expression of key genes implicated in the maturation, survival, degranulation, adhesion, and chemotaxis of eosinophils.
Mepolizumab is a humanized IL-5 antagonist, IgG monoclonal antibody administered subcutaneously. It controls severe asthma by selectively binding to the alpha chain of the IL-5, inhibiting IL-5 signaling, and preventing IL-5 ligation to IL-5A. This reduces the production and survival of eosinophils. Unfortunately, this type of drug may cause possible side effects, including headaches, back pain, and muscle spasms. Similarly, relulimab is an anti-IL-5 biologic, utilizing the same mechanism, however, administered intravenously and may have side effects including fatigue. Conversely, benralizumab is unique due to its mechanism of action and pharmacodynamic properties. Benralizumab is administered subcutaneously but binds to the IL-5 receptor, not the IL-5 ligand, increasing the direct action of the cytokine and effector cells.
Now, recalling the information provided, which of the following is correct? A, B, C, or D? Now, if you answered C, Non-allergic asthma involves hyperresponsive airways caused by the stimulation of IL-5 receptors, which results in headaches, treated by mepolizumab. If you answered C, then you're correct. Congratulations!